This is a life-saving medical device, and it didn't even work. This catheter tip is supposed to reach minus 185 degrees Celsius. That's cryogenically cold. That's like freezer burn your heart cold. It's designed to ablate faulty heart tissue and fix arrhythmias. But it had two major problems. The first, it was ridiculously expensive. And the second, and this one's much worse, it didn't even freeze properly. So let me show you how CREST tackled both of these problems head on. First, let me tell you how a catheter like this is supposed to work. Cold, high-pressure nitrogen flows into the catheter, freezes the tip, and then now warmer nitrogen exits out. Simple enough, right? But in practice, space was tight. There wasn't room for one large inlet tube and one large outlet tube, while leaving space for all other features. Instead, there were multiple small inlet and outlet tubes, each paired up at the tip of the catheter. To connect them, they were squeezed into a tiny metal housing and sealed with black epoxy to hold the pressure. Here's the catch. That high pressure nitrogen, it loves to leak out in the tiniest of cracks. And bad epoxy application meant, well, leaks. And the leak of a high pressure gas in the body is not good. Their team attempted to fix this issue by replacing the two tubes with one tube formed into a U-turn shape to create both the inlet and the outlet. But the U-turn was so tight, it created tiny internal wrinkles. And without proper assembly controls, those wrinkles turned into kinks. Kinks that are super small and hard to see, but large enough to choke the nitrogen flow and stop the catheter from freezing. Yeah, not ideal for something that's supposed to freeze heart tissue. This is where CREST stepped in. The following is a cross-section, an inside look of the large metal housing. And these are the paired inlet-outlet tubes housed within the tinier metal housings. It was in here that CREST identified the issue. The tiny metal housings were forcing those kinked sharp U-turns. So CREST proposed the following: moving the inlet and outlet tubes across from each other instead of right next to each other to allow for bigger, smoother U-turns. That simple change eliminated the wrinkles and kinks, restoring full nitrogen flow and proper freezing. It also eliminated all the tiny metal housings altogether, a huge cost savings. And no epoxy sealing meant a faster, simpler assembly. All in all, that single design tweak saved over $400,000 per year while giving the team a catheter that finally froze effectively. Sometimes the most powerful solutions come from looking at the problem a little bit differently. That's what we do at CREST. Solve tough challenges with simple, clear, real-world solutions. Want results like that for your product, your service, and your team? Let's connect. Schedule a call. We'd love to help find simple solutions so you can continue driving your solutions into the real world. Oh, and hey, if you enjoyed that dive into design and problem solving, show it some love with a like.